Okay, so here we've got an equation. We've got carbon monoxide reacting with hydrogen, and it produces a hydrocarbon and a H₂O. Although this isn't necessarily essential to balancing an equation, it may interest you to take a look at the Fischer-Tropsch process. I'm not going to go into too much detail about that, but it was a process which was discovered, or should I say developed, in around 1926 in Germany, and essentially it's a process which enables the synthetic production of hydrocarbons, which as you can imagine has a number of uses. So that can be, effectively producing it from carbon monoxide and hydrogen. And in this particular example, we're dealing with C₈H₁, but there's actually a number of different hydrocarbons which this process can produce. This is just one example of a reaction. But anyway, let's focus on the balancing side of things, shall we? So how am I going to actually approach this to balance this? And the question specifies that the final balance equation should use on the whole numbers. Well, the first thing I'm going to do is I'm going to audit my equation. I'm going to figure out what's the occurrence of each element on the reactant side of the equation, and what's the occurrence of elements on the frequency of occurrence of elements on the product side of the equation. So I'm going to abbreviate that. I'm just going to use left hand side and right hand side. All right, so left hand side and right hand side. Okay, so let's do left hand side first, right? So we've got carbon, oxygen, and hydrogen, right? So COH. So for carbon, how many we've got? We've got 1. Oxygen, we've got 1. Hydrogen, we've got 2, right? Right hand side, carbon, oxygen, hydrogen, right? So on the right hand side, carbon, we've got, as you can see, we've got 8. Oxygen, we've got 1, I guess. And hydrogen, we've got, well, hydrogen occurs in both of the product species, so we've got 2 plus 18, which would be 20, right? 20. And in effect, we need to work out also, well, let's first look at, well, what's balanced here and what isn't, right? So oxygen appears balanced at the moment, hydrogen isn't, carbon isn't. So what can we do? What can we approach first? Well, hydrogen is on its own, right? So H₂, we've got H₂ on its own, so I'm going to actually leave that. That's quite a useful tool to leave to the end. I'm going to focus on, I'm going to focus on the carbon first. So in the context of the carbon, if I add an 8 in front of the carbon monoxide, right, that should get this from a 1 to an 8 for the carbon. So I'm going to do that, and I'm going to see what's actually going to be the outcome, what we're going to get after that, right? So effectively, that's going to be 8CO plus H₂, and that produces CaH18 plus H₂O, right? Now, I'm going to audit this again, right? And look at, well, what numbers do we have now? What do we have on each side? So if you do that, left hand side, right hand side. So on the left hand side, 8CO, so we've got for carbon, oxygen, hydrogen. On the left hand side, we've added 8 to the CO, so it's not going to affect the number of hydrogens. So hydrogens would be the same. It would just be 2, just as it was before. For oxygen, on the other hand, we've put an 8 in front of here, so it's going to be 8 times the O, right? So it's going to be O8. Well, we're gonna have 8 oxygens anyway, and carbon similarly is going to be 8, right? Okay, so on the right hand side, we didn't change anything, right? So it's going to be more or less exactly what it was before. So it would just be 8, 1, 20. Okay, so at this stage, we now have a situation where the carbons are now effectively balanced, but by balancing the carbons, we've created a situation where the oxygens, which seemed balanced before, are no longer balanced, right? So what can we do? Well, the hydrogens are also not balanced. But as I said, we can focus on that right at the end, as far as the hydrogen. So on the oxygen side, what I'm going to do to try and balance that out, because the only place where it actually occurs on the right hand side, which is where it's not as many oxygens as we really need, is in the H₂O, right? So in order to get it from to be on par with the 8 oxygen as we see in the reactant side, I'm going to put an 8 in front of the H₂O. Okay, so if we write that out now, so right, and so let's audit this again. So we can use this. So left hand side, right hand side. So this is so we didn't change anything on this side, right? So it's literally going to be the same. So it's just going to be 8, 8, 2, right? So 8, 8, 2. On the right hand side, we did change something, right? So let's see what effect that is going to have. So C8, so that's just going to be the same, right? So 8 H. So in this case, 8. We're going to add, I have to do 18 plus effectively 8 times 2, which is going to be 18 plus 16, right? So I mean, if you do that, you should get 34, right? So for oxygen, we're actually going to have now 34. Oh, no, not oxygen. For hydrogen, we're going to have 34. And as we had aimed for, in terms of oxygen, we were trying to get it from 1 up to 8, right? So it's going to be 8, right? Okay. Now, at this stage, we've got seemingly a balance between the carbons, balanced with the oxygen, but hydrogen is not balanced, right? Now, this is quite a convenient situation now, because as we discussed right at the beginning, in the specific case of hydrogen is on its own, right? Which makes it at least on the reactant side, hydrogen is on its own, which makes it quite easy to balance at the end, because changing the coefficient doesn't affect the number of any other element, right? And here we've got 34, which is what it needs to be balanced with. So in order to figure out the number or the multiplier we need to go from 2 to 34, we just need to do 34 divided by 2, right? So if you work that out, you should find that gives you 17, right? And so this is the multiplier we need to use. So what I'm going to do is I'm going to put a 17 in front of the H2, right? So if we do that, we should get 8CO plus 17 H2 produces C8 H18 plus 8 H₂O, right? Okay, So at this stage, what I'm actually going to do is I'm going to work on auditing this, right? So I'm going to do left hand side and the right hand side. So just now, as you saw, we did not change anything on the we didn't change anything on the right hand side, so it's going to be just the same as what it was just now. So C O H is going to be the same. So 8 8 34. What we did do is we changed on the left hand side, we added the 17, right? So C O H. So we've got 8 CO still. Oxygen, we've got 8. For hydrogen, we've got 17 H2, which we know 34 divided by 2 is 17. Obviously 17 times 2 would be 34, right? If we now make a comparison between left hand side, right hand side, what do we find? We find that at this stage it is balanced. We've got an equal number of occurrence of each element on both sides of the equation, and as the question specified, we do also now have we've used whole numbers in each instance to do the balancing, right? So we've got whole numbers. So in effect, this is our balanced equation, right? So up here we'd have 8, 17, and then an 8, right? Okay.